Dobrodošli na junski rast, C++ meetup.
Okay.
Ovog mjeseca ćemo malo skrenuti s teme i preći na žal, ovo je bilo namerno, i preći na rast. Nebojša će se malo predstaviti, a posle toga ćemo krenuti, ja mislim, sa jednom zanimljivom temom za sve C++ inženjere koji žele da pobegnu C++ sveta. Welcome everybody. For non-Serbian speakers, I would like to announce Nebojša. Nebojša will present Rust and why it's sometimes maybe okay to choose Rust over C++, at least for new projects. So, Nebojša,
okay. I'm going to try to stand up without walking into the laser. Yeah, I want to talk a little bit about myself and then how this talk came to be and why are we pitching Rust in a C++ meeting. I worked in C++ pretty much my whole life since the 90s. I started with embedded stuff like microcontrollers, then worked my way through Turbo C++ and TurboVision and then Windows, and I made point-of-sale systems and things like that. And then I started working at Palm in Palm OS. I worked on their GSM library, a bunch of other things. I made a RAD UI designer. I worked on the Wi-Fi stack. I made a Linux distribution. What else did I do? I made a JavaScript debugger. And then I went to Google, and in Google I worked on Chrome OS. I worked on a native client. I worked on WebGL. And then I went to LinkedIn, and I was in LinkedIn mobile server when it was 3 people, and I was responsible for the mobile infrastructure. Then I went to Click Analytics, and then I went to, we did columnar databases, we did the traffic servers, and I sat on LinkedIn Technology Leadership Group, which is like 5 dudes that get to see everything that goes on in LinkedIn. The reason I'm saying this is the whole time I worked in C++. Like every single project, every one of these projects is like a relatively large C++ project. And so when I started my company, we chose Rust. So it's an interesting question. Why did we do that? And then I talked to Goran, and Goran was interested in hearing what are some reasons that like a hardcore C++ person would convert. And I want to start with a case study, which is Palm Folio, a device that nobody heard of. When I was working at Palm, we were working on this device, and it is basically an ARM device that was supposed to replace the laptop, right? This was before iPads and all that. So something like Chromebook before the Chromebook. And this is how these things are designed back in the day. We create a prototype, and then we make a list of all the issues, what needs to be implemented. We split that into teams, and you start working. And then 2 months later, we sit down and we try to figure out how far along are we, right? And so we started. I don't really remember what were the dates, so I started from January. We went 2 months into it, and then we draw the line, and we were like, how many open bugs? This many. That's easy. Then we just extrapolate, right? At some point, this is our quality requirement. We're not going to fix all the bugs. You got to leave some for the customers. And so we extrapolated, and we're like, at this pace, we ship in July. Awesome. And then 2 months later, we were looking at it like, that's looking pretty good, right? We had some kinks in the progress, so we adjusted the ship data. It's not July, let's be realistic, it's mid-August. Management was not happy, so everybody decided we're going to work extra hard, right? Like, we have to hit this estimate, it's a lot of money, everybody had stock. We started working, from 12 to 16 hours, weekend. We're going to hit this, right? And then we had another one of these, and we slow down even more, right? This is so not acceptable. Like at this point, we're gonna go back into the moon, right? And so we need to get back on game the same way we did at the beginning. Management made this emotional call. There was a pep talk. Everybody stayed late. Everybody worked in the weekends. Now we're going to the 6 months. And at the next meeting, all right, same thing, except you can feel the burn. People are tired. People are angry.
Se čujemo ako pričam na ovom? Nemate pojma koliko je opasno meni dati mikrofon. Znači, na karaokama su uvijek izbacivali napolje. Like, this is the most dangerous thing you can do. Like, not that I can't sing, but I love to do it and it's horrendous. All right, let's do it like this until the battery comes. So the next meeting, right? Leadership begging us, they have all the distribution deals lined up. They have the warehouses booked. Everything is ready. We're burning like, you know, something like 250K a week. Like, we need to ship this product, right? And we can do it because we're amazing. We're great engineers. Like, we've done this before, right? All right, next meeting. You can see what's going on here. We're now getting closer, right? Same rally close. We're so close. If we just get our shit together, right? And I got and asked the guys there, hey, we had the same situation in 3 meetings, right? And we decided that we just have to work harder, right? And now we decided that we're also going to work harder. Same course of action. Why do we expect a different outcome this time? Why is it going to work this time? Like if we work harder. My microphone battery is not vibrating. The same.
Can you hear me now? Oh, all right. All right, a couple of things. Didn't really work, did it? Like the whole let's just work harder. The project folded. Like if you can't ship it in a year, other people make other things. Chromebooks came, iPads came. And then this was Palm's last stretch, and they folded too. Quality is not additive. You can't get some crazy dysfunctional project to 95% there and just say we're just gonna work hard. Like you're never gonna fix it. If you make a pile of crap, like you can't add to it. Another thing that's kind of obvious in hindsight is that bugs are proportional to complexity, and as you work, complexity increases. And so what starts happening is like every time you want to fix something, you start having to touch more and more and more and more things until you get to a point that every time you want to fix something, something inevitably breaks. You can add engineers to the fire. You can add 10 more engineers, but they're additive, right? And the problem is exponential. And so if you look at any project anywhere, it's never going to be a straight line. There's always going to be a curve that comes close to 0 but doesn't touch it, right? And so how do you choose how close to 0 you come? Well, design and tools, right? You can work as hard as you want, but if the problem is of a certain complexity, that's how far you're going to get. And better tools make it less complex, and that's really it. And also, if you have management that this is just like, guys, work harder, work harder, just make the whole thing not obvious, right? They're hiding the actual problem. Nobody sat down to think what the problem is. Now, Wikipedia says, had it been released, the folio would have been the founding device in the category, but it wasn't released. Okay, so this is an example of a complete shit show, how to fail and lose $1 billion. Let's do another successful study, Topcrash. So does anybody know what Topcrash is? Mozilla's Topcrash. Back in the day, Firefox had a problem. Everybody loved Firefox. We were talking about version 1 or something like that. But everybody was saying it's very buggy. It's crashing all the time, right? And it was losing market share. And #1 reason listed was because it was buggy, right? And so I don't really know, at that time, I didn't know anybody in Mozilla. But I'm presuming they had the same setup we had. They had like talks with management was like, guys, like, get your shit together. But they didn't. What they did is they measured, right? In Google, they will like always tell you what doesn't get measured doesn't get improved. So they wrote Topcrash, and that's a system that collects crash statistics. Now, everybody here is like, oh, of course, everything uses like crash statistics, but back then it was like a novel idea. We're going to collect crash statistic in a database somewhere, right? And what it collects is all the stacks, crash stacks, and it also collects the configuration, like which plugins you had installed and whatnot. And then it got ranked by frequency, and if you can go to Topcrash, it gives you a list of top crashes, like top 10 crashes. And very quickly, it was obvious, like the crashes are not in the browser, plugins are crashing the browser. Adobe should well, I worked for Adobe, so I can't say what I want to say, but Adobe. And so a lot of interesting browser development came after that, right? Like we analyzed the problem and then we were like, okay, how can we fix it? And first thing that happened is out of process plugins. Like, you can't crash me if you're out of process. And if you crash me, it's not going to say Firefox crash. It's going to say Adobe crash. So go deal with your stuff, right? And then different kind of OS sandboxes were made. And then native client, which is where I worked on, which is like a compile time sandbox, that we get to compile something in a specific format, and then you can sandbox it while it runs. And then eventually, no more native plugins. Like if you say native plugins right now, people are going to lynch you. Okay. So let's talk about this first part of measuring, right? This was an example of how they measured and how they fixed something. And so when I was working at Chrome, 70% of all bugs were memory-related bugs, all of them, right? And we made a whole ton of tools, right? So from static analysis to different virtual machines, they can run it to like different thread analyzer, this analyzer, that analyzer, right? Meaning runtime instrumentation. And then there was a bunch of languages, for instance, wrangling unsafe file formats safely is like literally a language that just allows you to write file formats so you can't mess it up, and protobufs and whatnot. But this is where Rust came in, right? This whole idea of memory safety is not really old. It's pretty young. It's like less than 20 years old. There was an interesting paper where they analyzed the number of bugs that a program has. Because when you work in a company, eventually you will meet a bunch of graybeards who are going to tell you that only young engineers make bugs. But once you transcend bug making, once you become a graybeard, then you don't make bugs, right? And they analyzed a ton of programs, and they concluded a couple of things. First thing they concluded is there's simply bugs per line. Like this many lines of code equals this many bugs, period. If you're a better engineer, you have more years of experience, you can even cut that in half or in 10. But that just means that if you add 10 times more code, you have bugs. There's no escaping it, right? And then they looked at, well, does the choice of programming language matter? Like if I choose Python versus Ruby versus JavaScript, does it matter? And they came to conclusion that almost not, except language features do. So strongly typed languages have fewer bugs. That makes sense, right? Like, so when you write something, you write a piece of code. If you write it again, right, it's less likely that you would make bugs, right? But if you write it again in the same language, then you're probably going to make the same bugs. Static typing is exactly that. I'm going to rewrite the constraints in a different language, and I'm going to have fewer bugs. And it works, right? That's exactly what I just said. Type system, you restate the problem, you do it again. Like you write your thing, you added your math for your exam, and then you verify it by subtracting it. And the odds of making the same language means fewer bugs, right? So it was kind of reasonable to me to think that if I have type system that also talks about memory ownership, that we could expect fewer bugs, right? We're not talking about changing a programming language for the sake of changing a programming language. We're talking about actually restating something that you think about while you code in the type system, right? And our use case, first off, I don't think I've told anybody what we do. Hi, I'm Neb and I'm an alcoholic. We make glasses that change focus based on where people look. So if you're a certain age and you can't focus up close, you need different pairs of glasses for different distances. We have a device that looks at how far you're looking and changes the focus in the whole lens. Like I had my TV reboot the other day and I had a full-on fit of rage. I'm like, you're a TV, you don't get to reboot. You know, I plug in the cable, you show the video. So, but if you're like driving a fuel truck in the tunnel and your glasses decide that now is a good time for you to reboot, like it's kind of more dangerous, right? So we see crashes as more important than logic errors. Like it's okay if they decides, hey, maybe you need like half adapter more or less, but it's not okay if the thing just reboots and you have to wait 30 seconds for it to come back to life, right? So what are the options? Well, we talked about this. You can't get better. I mean, whatever your delusion is, but you can get better engineers to fix this. And then we looked at a couple of things like choose boring technology and do nothing. Boring. We looked at formal verification, which is exactly the same thing. Like you're going to restate the problem in something different. The problem with formal verification is like you think it's hard to hire C++ engineers. And then Rust. And that looked like it's kind of the easy, like it's low hanging fruit, right? Like you don't need to relearn everything. It's programming, right? And so we tried it. The thesis was fewer bugs. We do have significantly fewer bugs. And in particular, since we started it, we didn't have a single crash. And we use Rust for a bunch of things. We do run it on the device, but more importantly, we use it for our lens optimization. We use it for the servers that the manufacturers talk to. We use it for in our ML pipeline. We use it pretty much everywhere, and we've never had it crash. Other things, it's kind of nice, you know, nice. Like it's not like annoying to write like Java. You don't have to write books all the time. You can work on it in a Lispy manner. You can map, reduce, do those kind of things. It has, you know, lambdas, closures. It's kind of nice. So at Google, they use 3 languages: Python for all things scripting, C++ for high performance, and Java for everything else. Why Java for everything else? Because God forbid you have to write a little piece of programming in C++ that has to like talk to a server, get JSON, parse it, and bring it back. Like that's you know, that's a weak project. And in Java, you can actually do it. And so what we noticed is that like it does have the performance of C++, and I'll talk to that later. But definitely has the development speed of Java. So this is like 20 years of. So we can pretty much get away with only have 2 languages. Like we use Python for the ML stack, and we use Rust for everything else. It kind of works. The speed is sometimes better than C++. And the reason why speed is sometimes better for us, we do like data intensive stuff. I'm not saying that it's always better, but speed is better because of memory ownership, you can get away with not using a dynamic allocation of memory very frequently. And second, because it knows who owns what. Like in C++, I mean, we have, where's our he's not here. We have people who can write really optimized C++, but that means you have to say like on all the pointers, you have to restrict them. So the optimizer knows that they can't alias. And then you don't have to do any of that in Rust. You just write it and it kind of like just works. So I would say that the naive code is faster in Rust and optimized code is faster in C++. And everybody that starts working in Rust spends at least a month just cursing the compiler. This should compile, but it doesn't compile. And then like, you know, a week later, you're like, I see now what I've done. And it has automatic type deduction. But when we started it, it was pretty shitty. So when it doesn't know some lifetimes or whatnot, you get to sit down with a pen and paper and try to decipher it. They fixed that completely. And so now type deduction just works, right? Except for async. For async, type deduction is now the same way that regular deduction was like a couple of years ago. So rough edges exist. Awesome community, everybody wants to help, but like everything is a little janky. Be prepared to write some patches. Well, oh, it's much easier if you go forward. Oh yeah, and there's no UI. I mean, UI is just abysmal. I mean, you can do it, but and there was no community in Serbia, so we fixed that. So when should we use Rust? C interop is great. So if you have something in C and you want to use Rust, awesome. We write GStreamer plugins with it. Kernel, as you know, you can write modules in Rust. Glory, just like victory all around, flowers and unicorns. C++ interop is meh. We use OpenCV. OpenCV is a very header-heavy C++ library. So somebody wrote like an interop that actually translates between these two. And if you look at it, it's like heavy on the macros. And you can do it, but it's not pretty. There's also cxx.rs. By the way, Rust uses RS, like they come to Serbian domain because the extension is .rs. Just saying, if we wanted to be, you know, if we wanted to have a nice little URL, we could completely do it. Some things are better in Rust. Like if you look at 3D graphics or web servers or like or gRPC servers or like anything you want to run on the web or command line interfaces, crypto. Just the ecosystem is better. There's more stuff in Rust. Some things are just better in C++. Like if you, like I said, user interfaces, you want to do this in C++. Games, if you want to use Unity, you want to use something that's probably C++. Embedded is currently better in C++, but that's really picking up quickly. I think Rust is going to win there because it's just more ergonomic. And then if you do ML or multimedia, I suggest you stick with Python and C. And I would like to now switch to where you asked me what went how and what questions you have, because I didn't have any plan doing this. I was just rehashing the Rust meetup.
Yes, so one question, you mentioned like you had 0 crashes, right, in your project, and you compared it to C++.
So
we have previous experience with the project in C++.
Yeah. So we have one kind of big tool that controls the device, and it has some media components. It records stuff, telemetry and video on the device. It sends it over. So there's some multimedia the pipeline. It does a bunch of does all the computation. So we use a bunch of OpenCV and a bunch of other libraries to verify the computation. It's kind of hefty. It's big and it has a bunch of pieces, and it also works over the network and yada yada. And that particular beast has had 4 different iterations. The first one was in GTK-MM, C++. And then it had to work on Mac. And then we had this horrible Frankenstein, which was written in Objective-C++. Objective-C++ is bad, okay? And then we had a combo of Swift UI with C++ backend, and now we went to Rust. So we tried really hard to hold on to C++, it just didn't. And the reason we tried really hard is because of libraries that we are using that are C++ libraries. Yeah.
Are you still using?
Yeah.
And they don't crash.
OpenCV is not really crash-y. GStreamer is a little crash bitch. Some of them crash, some of them don't crash. We haven't had crash in our code.
Do you use Rust with OpenCV? You wrote it, yes?
Did I use Rust with OpenCV? They have bound. I didn't write it. They have bindings. We just.
I opened it and it's written that use at your own risk. And you wrote about car crashes, and I was afraid.
We don't use so for our device, it's a different story. We make a bunch of ML on servers, and then when we lower it down, it's in FPGAs, and it runs in Rust on a really small kernel. But a lot of development, so these are tools that we don't run on the device. We don't run OpenCV on the device. OpenCV is super slow, but it's kind of nice because if you want to try a couple of things, you can try it quickly. Same goes for whatever ML guys are using, PyTorches and this and that. We don't run any of that on the device. The device runs a really, really tiny FPGA. I wish I had one of those too.
You have the graph of bugs, and then it starts going down as the time goes on. But what's the number? How does that correlate with number of developers on the project? Because in my experience, like the huge amount of complexity doesn't necessarily only come from the code, but from the number of people working on the project. So as the number of people on the project starts going up, the bugs start going up as well.
What's the name of that law? Just a second. I'm looking something up because my memory is shitty. What's the name of the law? There's some law that says that the structure of the code maps to the structure of the organization. Somebody said if you want to have a 3-pass compiler, you should hire 3 engineers. I don't think you can really separate those 3, like those 3 engineers. No, if you can separate those 2. I don't have anything smart to say to that. Like if you have a great, if you have something huge, right? But you've managed to split it in such a way that you have a clean interface, and this team only works on their thing and they have a clean interface, then all of a sudden you don't have to deal with complexity, right? But if you have 100 guys working on the same project and everybody has, then you get into a shit show. And if your code is such that it just designs so everything talks to everything, you can't avoid engineers talking to each other. They're gonna have to. So
Yeah. What you said, you fixing the bugs and you had some magical exponential factor generating bugs at the same time that you're fixing it. The magical factor is the communication.
yeah. I'm not saying that it's magical. It's not magical. It's complexity. It's just that. Yeah.
It's not complexity of the problem, it's the complexity of organization. What the vendors were doing is like,
Of
we
course.
need to do it. They were hiring, like the complexity of the organization went through the roof, and that's why it's second. It's nothing to do with the language, nothing to do with the organization. Management made mistake. That's clearly.
Yeah, I would clearly disagree with that. Like, here's two reasons why I would disagree with it. One is, if the biggest team you work is 10 people, then you don't have any of these problems, right? You don't have it. Like 10 people, we can talk, we can sit in the room every time. Like these things don't happen. If you want to build something that you can build with 10 people, right? Now you can say, well, the original Unix was built by 2 dudes. We can build Unix. And now it was 95% built. And then the next 5% took the next 95% of the time. So my point was not that there's a better language for the job. I don't think so. My point was just to say that, like, as you develop things, right, you can't always solve things just by adding more engineers. Yeah. So sometimes you have to look at, like, is there something that you can that can significantly decrease complexity? And I will agree with you. In that case, maybe they could have had Slack. Maybe that would help them communicate. But maybe if they didn't have 70% of easy, but maybe if they didn't have 70% of the bugs, maybe it would go quicker. Just saying.
It's interesting that, like, first you're talking, like, I'm sure you read Mythical Man. It's
Which one?
Mythical Man.
Yes.
That's the premise of the book. But I totally agree with the type, stronger type system that you have, bugs. That's the only reason.
The first part of the talk is a motivation. Why would we even, right? Like, because most people were going to say, like, C++ works. Why would we even? Like, why would we go there? And my argument is just like, I like tools. I think they're cool. Like, on my build, when we had C++, we had every single sanitizer active. We had Valgrind, we had cache. Like, we use tools. We had coverage, and they help. And like, somebody gives you a tool and it fixes problems. Why would you not take it? So that was more like, why did we even sit to think about Rust? Because, you know, especially if you go in front of VCs, they're going to be like, choose boring technology. You already have a problem in your product. Why the hell would you, make another gamble on something that nobody else has proven? That's why.
Yeah, I have another one then. So is there anything that you miss from C++ when you switch to Rust?
I'm still better at C++, so I miss this feeling of just absolute dominance, like being like, lesser creatures can't even come in the room where I'm coding. No, I'm just kidding. I do miss some things. So C++ has many more libraries. Yeah, I have some more experience with it. I miss that. Rust is kind of new and changes a little bit.
Nerds?
No, fuck no. I have macros, yeah. I think generics are the root of all evil, really. When I was working on C++, I had this thought, and the thought is this: the thing is inherently complex, okay? And so you need to spend 20 years of like mastery, and then you should start writing code. And everybody that doesn't have 20 years of mastery, well, they can go make us some coffee or whatever, just fuck off, right? And then what I like about it is that people can be really productive in Rust without having to know, like, remember the previous talk where we went into, yeah, how many people in your org Your org is one of the best orgs in Belgrade. I just want to put that. I don't know if you know his company. It's one of the best engineering organizations in Belgrade. How many people in your org can read that code and be like, oh yeah? Huh? Well, I worked in Google, right? And Chrome was like the hot shot of Google. And if you're better than that, kudos to you. But at Google, I would say everybody could read it. Only a quarter of people would dare write it.
Oh yeah, I hope nobody touched that. You write it once, right? There.
So that's the plus. That's not what our code is like. Anybody can go look at it, understand it, touch it. It's not, there's no magic, like, right? And this is liberating. That means that all of a sudden, like, you don't have this 10% of people being the bottleneck in reviews. You can kind of like, you know, if you really want to go down the path of, yeah, no, I don't see why you would need generics. Like I really thought I was like a big fan of generics and I use it for everything because I really want to control what it compiles to. I like, huh? Yeah.
You're like nerds.
I wrote a bunch of library code too. I wrote our, like for Palm, I wrote we had kind of STL thing. I wrote a shit ton of it. It's just super hard to write, especially anything that even touches on multi-threading, right? Anything that even, like all those things are powerful in C++, but super hard to write, okay? And I like them because you can do things that you cannot do in C, but they're hard to write. Like, I mean, I don't know. I used to write C++ or multi-threading code, and every now and then be like, that was the wrong memory order for ARM, and that's why this barrier, like, once every 3 months, when I'm not watching and I don't have a debugger, decides to crash in front of the clients, you know?
I have one question regarding memory management.
Yeah.
Do you feel that Rust is better because it has some meaningful constraints, so to say, regarding memory management, or there are some other?
So here's an example. Here's an example. Let's say in C++ you have a unique pointer, right? A unique pointer is nice because when it goes out of scope, clears itself, right? And whoever owns the unique pointer has like exclusive rights to it, right? But every now and then you need to be like, okay, I want to read something out of that pointer, but I don't really want to own it or delete it. So the thing that I do, I just give you a pointer to the innards of it, right? Sometimes, for instance, let's say I have a unique pointer. No, you've done this before, and you call a function, right? And that function needs to just read something and comes back to you. You're not going to give that function the whole unique pointer, move it over there, and then it gives you back the pointer, right? It will very frequently say, hey, if this function is guaranteed not to take any pieces of it, yeah, here take, by pointer I frequently mean reference or whatever the fuck ever you want to call it, but it's a pointer, right? So now you have to think about like, okay, so I have this unique pointer and then I have this reference to it, right? And God forbid God forbid somebody grabs this reference, takes the address of it and stores it somewhere, the whole thing goes to cyber crash space, right? Rust just protects that. Here's the unique pointer, you're the owner. This other guy can have non-exclusive thing. The compiler is going to make sure that everybody behaving nicely, and at the end you can leave and exit. That's the full extent of it. When you talk about memory ownership, it's not something deeper than that. It's literally that. Like this, somebody has an exclusive ownership to it, and somebody else you can give like references to it. But the compiler is going to make sure that no shenanigans happen, that nobody, ooh, I didn't know that this is on stack or this and that. That's the only thing. And in 99% of the cases, when you write code, it's exactly as you think. Nothing. But there's 1% where like, oh, I didn't think of that. And that's where it saves you. That's the bug.
Maybe
He has the mic.
C++ is a little bit better in the last 10 years.
Cooling.
Yeah, external tools, is step analysis. Here in your example, I would say that maybe it's not a wise idea to pass a raw pointer that is
Reference.
Or the reference that has its origins in the pointer, but to mark it as a different type, and at least be able on a static analysis level to analyze that. And
Wait. When you have some big chunk of data, you pass it by reference, const reference. Is that not the case?
If you have an alias type which is its underlying thing is actually a raw pointer, raw reference, doesn't matter, but at least from the type perspective, type system perspective, is not it's not a raw pointer. And then some static analysis can jump in and say we cannot store it.
Yeah, and static analysis will do that. This is true. Some static analysis will do that.
Because we need to start analysis. I mean, because they agree
But type checker is a static analysis tool. It statically analyzes this thing before it's compiled, and then Rust actually, after the memory ownership is done, right? Then the compiler happens. So the GCC version of Rust compiler, they didn't do the memory ownership. So they literally compiled it without even looking at the memory ownership. So these are two very separate paths. My argument is just this: Rust has this path integrated. There's no two way about it. You can't go around it.
all for us. Memorable is great. I totally agree. I think the one was trying to say that you can create the same API environment in C++. And it's the same. You're like, yeah, you can do this unsafe stuff. Same way as you can do unsafe stuff in Rust by marking. And the wrapper that he was describing exists in order to explicitly say that these things are safe, and then you have unsafe stuff.
I agree with that in the same way that I spend a lot of time working in glib, right? So glib allows you to write C such that it's C++, right? Because what our class is really, it's just a function that guarantees this is the first pointer plus a namespace injection. So this is what glib does. Like every function has to begin with the name of the type underscore name of the function. The first parameter has to, so you can do this. Okay, you tell me, do you prefer working in glib in C, or if you have to work with objects, do you prefer to do it in C++? So I'm not saying that you can't do it. The part is, for instance, Rust has two more interesting things. For the linter, by linter I mean static analysis, something that's going to tell you, hey, you did a for loop and incremented a counter, you should have just used count. They have that built in. Cargo Clippy, your whole project just tells you you should replace you want to do package management, get your Conan on, right? Like it's integrated, it's cargo update. So don't discount that, right? That's the work, right? The fact that everything is just packaged up, available, and sure, you know about the static analysis tool and how to get Clang to generate all the include and whatnot, and that compile command JSON so that this thing picks it up, and like you've never got to a project be like, all right, I'm going to spend the next 3 days just setting up the stupid IDE, right? There's something to be said. You just fire up anything that supports LSP and it just works, right? There's Clippy works, your linter, there's one format, one true format. We are done with formatting wars. I say cargo format, and I just make a rule if code review has the word format, straight to trash, like we're done. So there's nothing bigger here. There's no like new programming paradigm. It's just nice and easy, and you can bring junior engineers to much more complicated things quicker. That's the full sales pitch.
You mentioned the Mozilla study, you said like 70% of.
No, this is Chrome. This was in Chrome. It's not a study. It's not a study. You can go, Chromium bugs are open source. Just go there, type crash, 70%.
Okay, but I want to compare, as I understand, Mozilla is championing like Rust, right?
No, they're done. Those people are fired a long time ago.
Okay, cool. I was interested whether there was any comparisons, like, okay, we
so
some piece of code to Rust.
They did. So Firefox had this quantum project where they replaced pieces of it. So they had a full browser written in Rust called Servo. We spill a little bit of alcohol for Servo because Servo died a horrible death when Mozilla didn't know how to make money. But they moved pieces of it. So for instance, their C++, not C++, CSS. Their CSS engine Stylo is written in Rust. And so the things that they did move, they actually have significantly fewer bugs. There's two problems. One, it doesn't help with logic bugs. So if your CSS engine just decides to, my favorite mug is that like I love CSS and the border is like 50% off, right? It doesn't help with logic bugs. And I think the bigger problem is in browser, the API is just so humongously big. So you would really have to fix everything, right? So they started doing that. I don't think server crashes, but it's a piece of shit browser.
My next question would be like, if in C++ 70% is memory errors, like what's the biggest source of errors in Rust?
The biggest source of errors, that's a great question. Let me think. I mean, in my particular problem, we're dealing with a bunch of math. So my problems are like I spend 2 weeks because I couldn't figure out how to compose like non-linear transformations. So I'm not really, I don't know. We have a lot of logic bugs. Like we write like servers, and the servers very frequently give you wrong stuff. Another thing is in Rust, the memory, there's no exceptions. So if you want to return an error, you return, there's an error type result, which is kind of like an option, just carries it. And this works really well, except when you're lazy and you can just say unwrap, right? So we've had that happen where like instead of you returning an error to the user, somebody panics and just dumps the whole stack trace. I mean, it's easy to fix, you see what they did, but you kind of want to return the error to the user. So logic errors, I would say logic errors are by far the biggest one.
So that's not a memory bug? That's a
somebody gives me a parameter, and this parameter has to be, I don't know, convertible to float. It's a string, right? I say convert to string, and the thing returns error. I just unwrap that. The thing says your thing crashed. I tried to convert this to this and didn't work. Okay, it's like an exception that you didn't catch.
Yeah, I thought it was like a null reference.
No. Just like logic errors only. We had so many logic errors. Yeah, but the problem that everything is a logic error if you apply yourself. The problem with it is that it crashes not on your terms, right? Like,
Is there any form of contracts? I'm really not familiar.
so you need contracts in Rust in C++ because it's untyped. So contracts are classes for type parameters, right? But in Rust, you would use the same thing.
Concepts.
Oh, contracts. Sorry. Okay. Contracts, you can actually do it. There are libraries that do it. You can specify preconditions, postconditions, and whatnot. There are libraries that have it. Because they have something called derive macro, where you can say, like, every time I put this annotation in a function, do this and prolog this and that. So you can do that, and people do it. Not a fan. I mean, I haven't used them much. But...
You also mentioned like memory ordering and multi-threaded program.
Yeah.
Did
So-
you have any experience with that in Rust?
Yeah,
And
yeah,
Did
yeah.
you get any help from Rust in
Yeah.
that?
So the reason, when you think about, and again, Dushan is they're the only ones that are doing something that really requires high performance. But the majority of people really like things like actors or message passing or whatever, because if you grab something, process it on a thread, and then give it to somebody else, and you can't see it anymore, right? That's the best way to like not have shared state, right? And so Rust, first off, in the standard library, they have really good infrastructure for any kind of queue setup, message stealing, whatever you want to do. And then this whole memory ownership talks to you about exclusive versus non-exclusive access, right? And if you have exclusive access, you have a guarantee that nobody else can change it, okay? And if you have non-inclusive access, again, you have a guarantee that nobody else can change it. And so it actually helps significantly, mostly in multi-threading, because you can't have a situation where two of you are changing the thing because you both think you have exclusive access, right? That's the core of the problem. The core of the problem is you're modifying something, thinking, aha, nobody else can modify this, but you have somehow spaced out and forgot that somebody else has. So compiler prevents that. So I would say if I look at which programs are the best to move to Rust, I would say heavily multi-threading stuff, just hands down.
I don't know. Well, I don't know how to define this question, but how these advantages manifest in terms of like
Bugs.
compilers,
Oh,
like you're writing the code, right? And
I wrote the C++ thing, and it's supposed to process thing, and it has a bunch of like, it takes things from two different eyes. It tries to figure out, are they coming at the same time? Like things are super asynchronous, right? We make it and it kind of works. Okay, and it crashes every now and then. 3 months down the line, somebody manages to have it running in a debugger while it crashed, and spends a bunch of time because somebody was playing with replay debuggers. And we catch it and we're like, oh my God, we found it. And then a month down the line, somebody's like, oh, I figured out why sometimes when we turn it on, like it doesn't want to connect, right? So you have these bugs that it just takes time to like, and once you had something and you've been working on it for 3-4 months and it doesn't crash, you're like, oh, now I have confidence that it works, right? We don't have that. There's no period of time when you, like if it passes the first time, it's not going to crash. Like it's a little bit more reproducible.
and does it affect your test suite, like collection test that you're doing writing?
So the tests that we do, we do tests because of the logic. So Rust again has an integrated testing, whatever harness. So we actually, because it's easy and super, like you just bang test, write a test in the same thing. I actually found that we have more tests in Rust than C++. There's one way to write tests. Everybody knows that way. There's no like, oh, they use Google test or this or Mockito, or there's one true way. It's simpler.
I mean, or it's like another person, investing person. So how about Go? Why not Go?
Love Go. So Go was designed to replace Java, right? And Go had a very interesting, the premise of Go is I want it to be as easy for an engineer coming out of college to be productive and start working, right? And when you look at Java, Java is a beast, especially how they had it at Google, like with the dependency injection and yada yada. And like you have something running, you have no idea what's actually running in production. You have to look at like a bunch of XML files. So their goal was this: let's make it super, super simple, because the majority of the code that we write is business logic. You get this JSON, parse this JSON, the dude wants this, go talk to that server, give it like, let's not bring pen and paper into this. Let's make it as simple as possible. And so if you're doing servers, Go is amazing. Like your little cousins can work in Go, right? So that said, some choices that they made, such as garbage collection, right? Make it. That means if you have a JSON coming in and it's streaming and you're getting it in chunks, then you have to wait for them and assemble them all. And you have like memory pressure. Or if what you're doing, I'm presuming Go would be a horrible choice for any kind of latency sensitive thing, because at some point it's going to be like, I know you wanted this 10 milliseconds ago, but I'm garbage collecting now.
Oh yeah, but Go is good about that because it doesn't have stop the world garbage collection. Just
New Java doesn't have stop the world,
yeah,
but
it's paid. It's free.
Yeah. I'm a big fan of Go. I would, if I had like a simple web server that does business logic, I'd do it in Go. Stable. Okay. I think I don't like to live that dangerously. Like, why would you? So this was a legitimate choice back in like around Rust 1.10. It was a legitimate choice because it was moving so much, and like they would add stuff. But now in Nightly, there's just pain. You what? Yeah. I can't wait. So if you're doing anything with async, I think Nightly is the way to go. But I can't have my whole CI infrastructure crash because somebody added a new Clippy lint in Nightly, which happened. These are all things that happen. So I would suggest that if you're doing anything production related, if you really need those generic associated types, maybe go on vacation 6 months, come back when it's ready. And I mean, it's a nice feature. It's a nice.
The latest version we managed to compile our own text, so we can always rollback to a specific version.
Again, depends how many people you have. So if you have a company where like 20 people are working on something, you can't keep them all on the edge, right? So I think those are all legitimate choices. We've tried both. We do stable for now. Thank God we don't need anything in nightly.
Yeah, okay, great talk. Thanks for the pitch. So you mentioned that you had some experience with writing math in Rust. So now I'm
With what?
interested in math.
Yeah.
So I'm interested, do you have any experience with manually vectorizing code in Rust, and does it have support for operator overloading?
It does have support for operator overloading. Sorry, it has sim types in it, so you can do that. It has a couple of great tools that we use, such as cargo assembly, just type cargo, and it gives you assembly of the function, so you can really, and that's integrated in Visual Studio Code, so you can just click something and be like, show me how this, what assembly code it generates. It has great profiling tools, so you can see what's going on. Yeah, and there's a bunch of math libraries that are kind of cool. I mean, we do a bunch of it integrates with ML stuff is not the best, I wouldn't say, but it integrates. We do a bunch of math geometry. They have good GL kind of GLM kind of math, if you want to quickly do simple vector math. It's all optimized and it all works on multiple lanes.
Okay, I would say there are no more questions for Nebojša. Nebojša, thank you very much.
Very well done.